Rethinking, second edition, chapter 15, and we're on the hard questions, question 15H3. If you're, of course, going to run anything in this Colab sheet, make sure you've ran these first several cells here, and that in runtime you are in R. Okay. So let's go down here. Okay. So all of this is the question, and you can read it. But what we're going to do is we're going to generate some data, x and y. So x is going to be a standard normal variable with one NA or missing value tacked onto the end, and then y is going to be another random variable, not standard normal. It's going to have a mean of whatever x was, and then a standard deviation of 1. It's just implied in the code that's provided for us. And then instead of tacking on a NA value, we're going to tack on 100. Okay, so just kind of imagine what this looks like. So we have a bunch of values centered around 0, right? Plus an NA value, and then y is a bunch of values also centered around 0, and then one value of 100. Okay, and then we put that into a list. And then we're going to fit this model right here to it. And in the first case, we're just going to use complete cases. So we're going to ignore the NA and the 100. And then in the second one, we're going to try to impute the NA value and look at what happens to the posterior distribution. Okay. So here I'm just running the code that's provided to us in the question. And this is what it looks like, right? So again, we have a bunch of x values that are centered around 0, and then an NA value. And then a y that is centered around, also around 0, but really around, the corresponding value of x. And then a final value of 100. Okay, so first we run the complete cases model. Okay, so here it is. And so for D, I just have D, and then I'm just specifying the complete cases of D. Okay, and then we get all this. So nothing really to see yet. But now we're going to try to use the full data set, which includes this, this guy right here, the NA 100. Okay, and so I'm going to impute that. And so to impute that, I just need to put a distribution in there for x. And I think it's important in the rethinking package to make sure that the imputed value is right below, where you need to impute. For some reason, when I change those orders, it doesn't work. Just some quirk in how the rethinking package passes things to stand. So if you're struggling, make sure it's in that order. Okay, so we do that, and now we have both summary outputs here on the screen, and you can see that there's obviously something going on, well, kind of all over the place, but something very noticeable is going on with the b parameter, whereas it should be around 1. I think around 1. Now it's, kind of all over the place, right? It's like negative 22 and so on and so forth. Okay. So so what's the problem here? What's happening here? Well, obviously it has something to do with this weird outline value with 100 for y, right? Whereas everything else was centered around 0. Okay. So we're supposed to inspect the entire posterior distribution. I actually don't need this. I went a different path ultimately. So we need to look at the entire posterior distribution, and so the question is stressing that we look at the full density, and then it's also telling us that information flows among parameters in all directions. And so I think that what we need to look at is the relationship among the parameters, and so we can do that with the convenient pairs function. Here I'm just using suppress warnings because some warnings come up about graphing parameters or whatever, just to make this look cleaner down here. Okay, so when we look at the first model, the complete cases model, and we look at the parameters, let me actually zoom in here, it's hard to see. Maybe you can see that, I hope you can. Let me try to zoom in. So this little left kind of quadrant here, it's the parameters between the different value or the different parameters. So this negative 0.04 is the correlation between A and B, and here is between A and sigma, and so on. But you notice that they're all basically 0. Okay. But now when we look at the imputed model, here, we see some correlations that are reasonably high. Okay, and you can look at each of these, but the intriguing one, or I guess for our purposes here, the intriguing one is the one between b, or the beta coefficient, and the x imputed. Okay, it's rather large. Okay, so hopefully this starts to give some intuition about what is going on here. Okay, in this second model where we have to impute a value for the very high y value, the model is having to do some negotiation here. On one hand, it has to fit a beta coefficient that gets the predicted value of y to be, 100 or something. Okay, so that's going to be a big beta value. But on the other hand, x, the thing that beta is multiplying, is constrained to be between 0 and 1. Okay, so if you have a little itty bitty x value, well then the beta value has to get bigger. Okay, so I hope that makes sense. If you had a little x value, well then beta could be small. But anyway, so as we're imputing these values for x, it's imputing, and so smaller values of x are going to create the need for a larger estimate for beta, and larger values of x are going to create a need for a smaller value of beta. Okay, and so hence there's this correlation then between the imputed values for x and the beta. Okay, okay, I think that's good.